Okay, all right, there it is. Now, okay, first step here. Let's label our A, our B, our C. A is 1, correct?
Yes.
B is -8. If we're not paying attention, I'm going to get super irritated, Gabriel. All right, and C is 13. Okay, so just label those up. We're good to go. Now what? Who's got a hand to help me? David.
You gotta do negative b over 2a.
Negative b over 2a. Negative b over 2a. Yes, and I'm going to put it right here. I'm going to put an arrow right here. And I'm going to put negative b over 2a. Because if I do negative b over 2a, it gives me this value right here. The x value of my vertex. And I'll put another note here where I'll put negative b over 2a. And I'll put a parenthesis here. And I'm just keeping this as well as I can to give you some help here. This is the x and the y of what we call the vertex. The vertex is this x and this y. Okay? So let's go ahead and solve negative b over 2a. Why don't you do that on your own right now? And then maybe compare with your partner. Yikes. So as I solve this, negative b would be negative 8. That's a double negative. All right, so negative b over 2a would be negative 8. Does that make sense? Negative b, does that make sense? Over 2 times a. Which that turns into negative over negative. That's going to become positive, right? That becomes 8 over 2, which equals 4. So does that make sense that this is going to be 4? So that's your first step. Negative b over 2a. That x value tells you the x of your vertex. Now, you could figure out the y by taking this 4 and plugging it into the equation. Before you do that, let's go ahead and do what next? Wayne. We have 4 here. Keep thinking. Keep telling what you're thinking. Where?
In the x.
So he's saying in the x values, I can either go down 2, up 2. Doesn't matter which way you do it, does it? You're still going to have the same values. So I'll go up 2, 5 and 6, and I'll go down 2, 3 and 2. Now that I have all of my x values, I can now go about solving my y's. So I'm going to rewrite the equation. Y equals space minus 8 times a space or parentheses plus 13. All right? You guys now at this time, go for it on your own. And I'm going to go ahead and do this. Let's see if my screen's hopefully still recording. Excellent. And I'm going to keep going through this and recording as I do this because, pay attention, we're going to do the 4 first, right? Where does the 4 go? We're going to put the 4, this 4, where does it go? We're going to put it here and here. Make sense? Why don't you go ahead and do that for me? Are people able to use their calculators during this time? For sure, yes. But the problem is when you use your calculator, and I want you to use the Desmos calculator, that's usually the best one to use. Make sure, and I'm going to put this on the screen too, that you set it up properly with parentheses. So as I do this, all right, so my calculator's chilling, right? Let me see if I can make it other way. So if I want to set this up properly, would I go something squared? So if I did, what is it, 4? And then I put the exponent squared. Does that make sense? Something squared. I use the exponent here. Minus 8 parenthesis. Is it 4 in this one? 4. Plus 13. Now you could obviously do this on your own, but this is another way to check your work and see if that is right. And is that correct? If I do 4 here and 4 here, this becomes 16, negative 32, plus 13. I know this becomes negative 16 plus 13. That becomes, hello, come back. That becomes negative 3. Let's see if that, was that true? Was it negative 3 when I was doing this? What happened to it? It went away. Where'd it go? Oh, I can't find it now. Hold on. I'll find it. Come back. Where did you go, you little stinker? Oh, that's the wrong one. Get out of here. All right, hold on. All right, negative 3. That's what we wanted. Beautiful. I'm going to put that here to make sure that doesn't go away again. And I'm going to clear all ink. So my math is correct the way I set this up. I would double check to make sure when you do it on the calculator. Now, is it super simple now? Because what am I going to do? I can just go ahead and push in a different number, right? We just did 4. What if I did 6 now? 6 here and 6 here. And what do I get? 1. Okay, so let's go ahead and put that on there. So this is going to be, what was this, negative 3? And this was 1. If this is 1, is this 1? Okay, we're good. Now, the last step. We're going to do the 5. And we get negative 2. Is that correct? All right, I want you guys to actually graph this on your graph. I'm going to put a couple more notes on the graph when you do it. Draw a graph on with your graph paper, okay? So you have your table here, draw your graph. I'm going to write down my data too. This is going away, okay? You got it written down? All right, let's draw a graph. So if I go, I know it's not the most beautiful graph, but we're going to deal with it. It's going to be over 4, 1, 2, 3, 4, down 3, 1, 2, 3. Okay? Over 3, 1, 2, 3, down 2. Over 2, up 1. Over 1, 2, 3, 4, 5, 6, up 1. And then you can start to see the pattern. This is going to be what, over 5, 1, 2, 3, 4, 5, down 1. And that's my graph. How many times does it touch the x-axis? How many times does it touch the x-axis? Twice. Gerardo says twice. Is he right? Is Gerardo ever right? Just kidding. Gerardo, you're correct. Good job, Gerardo. Gerardo, you are correct. Good job. So, Gerardo's offended now. Never mind. I lost him. All right. Gerardo, we're going to plug this in, and you're going to see some more information on this. So if I do this, oh, that got caught on video too. I apologize to my viewers. I was just kidding. It was a prank. All right, now minus 8 and plus 13. Okay, so take notice. This is the graph you just created. I plugged this in. You could always use this if you want to. This is a Desmos graphing calculator. You know those fancy calculators that have the bigger screen on it? They're old school, like TI, whatever, 83s and whatnot. Those are graphing calculators that can help you with this. Now, if you had to, where does it touch the y-axis? Do you see where it is? So what do you notice about this 13? What do you notice about this and your function here? 13's right here. So this number, this C is your y-intercept. Always. The C is always going to be your y-intercept. Why does that make sense? That means when x is 0. Does that make sense? If x is 0, this gets destroyed. If x is 0, this gets destroyed. All this is gone. All that's left is C. What if there wasn't a C? Where's your y-intercept? At the 0, at the origin, okay? So it's interesting that you guys can start to see what's going on here. All right, we'll stop the video here. Hopefully that was helpful.